Right. So, time period of a pendulum. How can you figure out how much time it's going to take for the pendulum to complete one time period? Now, first of all, what do you guys think one time period is? Let me ask you guys, what do you think the definition is? See if you guys can get this right. Okay. Do you guys think, say this is swinging back and forth, right? So back, forth, back, forth, back, forth. Right? Do you guys think that one time period is defined as from the left to the right? Or do you guys think one time period is defined as from the left back and forth to the left again? Yeah. How many of you guys think the second thing is said? Yeah. So one full time period is like back and forth, right? So, right, so back to the original starting place. Now, how can you predict, like mathematically, how much time that'll be, right? Well, what variables could possibly be involved would be a good question. I guess kind of got them written up here, or at least most of them, right? Maybe I'm missing one, possibly, right? Maybe the mass of the pendulum, possibly the mass of this bob, right? Now, when I say this mass, we're assuming all the mass is in the bob and that the string itself is negligible mass, right? Speaking of the string, maybe the length of the string could have something to do with it, and maybe the starting angle from the vertical has something to do with it too, right? And then also, what variable do you think could possibly matter that I did not write? Like if you opened up a textbook and you actually found the answer to this, based on past experiments, right? What variable do you think I left off that could possibly be important? Gravity field. Gravity field, right? I left it off because we're all stuck in the same gravity field, so we can't really treat that as a variable, right? But that does show up in the textbook equation, so we'll think about that later, right? So we have these maybe 4 variables that we're juggling, right? Now, 4 variables that we're juggling. You guys remember from past experiments? Well, that's going to set up multiple experiments. In this case, 3. There's 3 experiments we got to do, right? I see some of you guys copying down this table, so you're getting a head start if you are copying down that table, okay? So I could probably have you guys come up with this too, but just to move things ahead a little bit, right? These are going to be the 3 experiments, basically, right? So what are we controlling? What are we treating as independent? What are we treating as dependent? So we're going to relate everything to time period. Time period we're going to treat as for like the dependent variable, right? Right. So let's go through these one by one and come up with some hypotheses. Maybe I'll do a show of hands for some hypotheses, right? One variable you could change is this angle. Now this is the angle from the vertical. So as you're measuring this, remember you're going to use a protractor to measure the angle. I'm talking about this angle, right? Now, how could you measure this angle? We're measuring with respect to the vertical. So in real life, of course, there's no vertical dashed line. So you have to imagine that, or maybe have another string hanging down or something like that, right? Okay. And then I want to get what is the size of this wedge. So I'm going to take this node of this protractor and park it right on that corner and see what is angles to sweep out to. It looks like on my picture, it sweeps out to about 33 degrees, just looking at my picture, somewhere thereabouts. Right. I'll walk around, help you guys use the protractor, like that, right? No, if you're changing out the angle, then you have to control, well, the mass of the bob and also the length of the string, right? Okay, so that'd be one. Right. Let's do a hypothesis. As this angle goes, say, like 5, 10, 15, 20, 25 degrees, as you make this angle bigger, right? What's happening to the time period? Here's 3 possibilities. One is that for an increasing angle, you have an increasing time period, right? Let's say it takes longer to go back and forth, swing it back and forth slower. Right? Second possibility is that maybe a larger angle from the vertical makes it swing back and forth faster, that decreases the time period. And the third possibility is maybe there's no relationship at all. Maybe you change this angle and it's the same time period over and over. Right? So let's see, show hands. How many of you guys think that a larger angle is going to correspond to a longer time period? How many of you guys think that? Okay. How many guys think a larger starting angle corresponds to a shorter time period? And how many guys say as you increase the angle, it's going to be pretty much the same time period over and over and over? Right. Okay, so I'm seeing different different hypotheses going around, right? So different show hands of different ones. Right. How about what if you change out the mass? Right. So you guys have a box of lab weights, right? You know how many grams or kilograms those could be quantified, right? So if you control the length and the starting angle, let's say you do like 50 centimeters over and over, and you do 20 degrees over, just for, right? But you change out the mass. Okay, so same 3 possibilities: larger and larger masses. Maybe that causes increased time period, decreased time period, or the same time period. How many of you think larger mass is going to correspond to more time to swing back and forth? Who says that? How many of you guys think, show hands, a larger mass is going to correspond to a shorter time period? And how many of you guys think that as you increase the mass, the time period is going to stay pretty much the same? All right. So different shows of hands on different of those. Okay. And then the third experiment we could do, the length of the pendulum. So as you change the string, the length you're actually measuring, you guys have meter 600 dust, so you probably use that. Right. Go from this node, right, where we're swinging back and forth from, to the center of mass of the of that pendulum box, right? The center mass, right? Kind of side note here, as you use larger masses, they are shaped differently, so that will lengthen the pendulum a little bit. Maybe you want to think about that too in the back of your mind, right? But if you control for that really well, right? If you're, thinking more like this one, right? So if you're changing length, if you're explicitly changing length, right? And so same three set of hypotheses. How many of you guys think longer lengths is going to correspond to longer time periods? The longer the pendulum, the more time it takes to swing back and forth. Okay. How many of you guys think longer length is less time period? And how many of you guys think the longer the length would be like the same time period? Right. Okay. All right. So it could be any one of those, and then we could get more specific. So I saw a lot of you guys raise your hand for longer time period for longer length pendulum, right? Now, if that's true, and maybe you guys find out, right? Then maybe we could get more specific. So is it a direct relationship? Is it a square root relationship? What kind of thing like that, right? So here's the table that all you guys are copying or have pretty well copied, right? So I got the section into 3 different experiments, right? And then across the top here, you're controlling for a couple of these variables at a time. One is independent, one's dependent, right? Okay. You need some units on these. So mass, pick a unit, pick either grams or kilograms. Right. Angle, I put degrees because you guys have a protractor for those. Right. Now, kind of side thought from last semester. If this angle ends up being imported in an equation, degrees could be okay as long as it's inside some kind of a sine or cosine. If you directly multiply an angle by something, then you would have to switch to radians. Maybe the fact that I don't have a column for angle and radians is a hint for how this is going to turn out. Right. Length, pick either meters or centimeters might be good options. Right. And then time period. You guys have stopwatches. Right. I have a column for 10 cycles and a column for 1, right? So you gotta remember this from last semester too, is that if you do 10 cycles and then divide by 10, that also divides your error by 10, right? Versus if you just let it go back and forth once, you try to time that, it's probably not super accurate. But if you let it go back and forth 10 times, and then divide by 10, whatever your error is also gets divided by 10, right? So it's a lot more accurate. Right. You guys good so far? You know what, in case I end up using this particular video for all my classes, a side thought for AP also is that AP would want an additional step of having multiple trials per set of variables. So like 3 of these and 3 of these and 3 of these and 3 of these and then 3 of these, right? So they'd be like this whole table would be like 3 times as much, right? So instead of having 15 total trials, might have like 45.
What is the first variable in the front box?
This one?
Next to it.
That one?
Oh, did I just say trial?
Oh, it said, yeah, trial unit. That's it. All right. Yeah. All right. Oh, so you should be able to get all your data today, and then if you keep a pretty good pace, you might be able to make some of the graphs today. I'm gonna have you guys make 4 graphs. Right? So 3 of these have the variables labeled anyway. Right? And then, one I got kind of a mystery graph. There's one manipulation we're gonna do. You guys remember manipulating axes last semester, like linearization it was, right? So like maybe you have to possibly square one of these variables so that the points line up in a straight line, maybe something like that. Maybe that could lead to some kind of proportional answer, right? Right, and then how this has been paced out is, you should be able to get all your data today, make 2 or 3 of those graphs, and then tomorrow in class we'll put these graphs together and finally get a proportional answer to this whole lab, right? So I will walk around and help you guys out, and let me close this recording.